Welcome to our solution to problem 4D from Superquiz 3. Again, we're given a series, and this time, we still have an n squared in the denominator, but now we have this weird sign of n with an absolute value around it in the numerator, and we want to know whether this series converges or diverges. So we've seen several times in class that when we get a sine of n or cosine of n, it's really good idea to put some bounds around it, right? To estimate this, get rid of it, right? Our goal is to use the comparison test. So let's note that the sine function, that lies in between -1 and 1. If I take the absolute value, then you can't get any more negative numbers, so this will actually be bounded by 0. And so this was taking the absolute value. And if I then divide by n squared, of course 0 divided by n squared is still 0, but now I can get the absolute value of sine of n over n squared is less than or equal to 1 over n squared. And again, everything here was positive, so in particular n squared is positive, so when I divide, I'm not going to change the inequalities. All right, so why is this useful? Well, this is useful because I now know I can compare the series for the sequence, absolute value of sine of n over n squared, with the series for 1 over n squared. And we actually know something about that latter series. This is a p series with p equal to 2, and so it converges. So this converges by the p-test, right, with p is equal to 2. Okay, we know though 1 over n squared is positive, right, for all n. We also know that the absolute value of sine of n over n squared is going to be, well, at least 0 for all n. And so these are the hypotheses for the comparison test. So by the comparison test, right, which says, okay, if you have two eventually non-negative sequences, that if you know that one of those sequences bounds the other one, and if the series corresponding to the one you know converges, then the series corresponding to the bounded one also converges. So by the comparison test, the series we're starting with, the absolute value of sine of n over n squared, this also converges.